All right, the set is really the new stuff that we just did in the task today, the in-betweeners. And so what we're noticing here on this 12, the growth of the table is tripling each year. That means this big jump is times 3. So we can fill in all the whole numbers. 6 times 3 would be 18. 18 times 3 would be 54. 54 times 3, 12. 162. So that was what we did back in Math 1, but now we're being asked in Math 2 to fill in these in-betweeners. So some values in between that are not going to be multiplying by whole numbers. So let's go use our geometric mean method from in class today and see if we can find this in-between multiplier. So this is a function that begins at 2, multiplies twice by some unknown r. So we say 2 times r twice is going to equal 6. So if r squared equals 3, square root, I get that r is equal to root 3. So this first r right here is a root 3 each time. Notice it's half of the 3 jump. It's root 3. It's not 3/2. It's root 3. So 2 times root 3 gives me 2 root 3. 6 times root 3 gives me 6 root 3, and so on and so forth. So in this first one, my multiplier is root 3. Okay, let's go do the big jumps and then try the in-betweeners on this next one. From 2 to 6, that's a big jump of 3. From 6 to a big jump of 3 would also be 18. So this time, there's my big jump of 3, but this time instead of being divided into 2 jumps, it's being divided into 1, 2, 3 jumps. So this is a function that begins at 2, is multiplying by r cubed this time, times r, times r, times r again, and this time we'll land at 6. So this time when I divide, I get that r cubed is equal to 3. And when I square root that, I don't square root it. How do I undo r cubed? I cube root it. So this time my r, when there's 3 jumps, is cubed root of 3. So here I go multiplying. 2 cubed root of 3, 2 cubed root of 9, 6 cubed root of 3, 6 cubed root of 9, 18 cubed root of 3, 18 cubed root of 9. Now, by the way, where is this cubed root of 9 thing coming from? The cubed root of 3 times the cubed root of 3. Today in class, we reminded ourselves that when we're multiplying radicals, you can put those things under the same house. So cubed root of 3 times 3 is just equal to cubed root of 9. Okay, we're down here on this last one. Notice the jump here is a times 4. So the big jump here times 4, big jump here, and big jump here. $128 times 4. Let me do a calculator. Good, I did get it right. Okay, so there's my big jumps, but I'm trying to find the in-betweeners. So I go set up my little geometric means equation. So starts with 2, 1, 2. We're multiplying by r squared, 2 jumps, equals 8. So I get r squared equals 4. Oh, it's just 2. So 2 times 2 is 4. 8 times 2 is 16. 32 times 2 is 64. 128 times 2 is 256. This one worked out to a nice whole number. Yay. All right, the go is just a really short, quick review on exponents for you to try tonight. Pause the video, see if you remember these, and then let me know if you think you need to review these. So this first one is the add rule, that when I'm multiplying two same bases, 3 to the power of 2 times 3 to the power of 5, I just add the exponents. Have you ever seen that rule before? Next one is the subtract rule, that when I divide two of the same bases, I just subtract those powers. Next is the negative exponent rule. Anything that's negative 5, power of negative 5, is going to be repeatedly dividing by 5. Negative exponents move down. If they start at the top, they move down. If they start at the bottom, they move up. Anything to the power of 0 is just, you got it, 1. This next one, you could do the add rule, then the subtract rule, or the subtract rule, then the add rule. It is your choice. So here I would go 7 to the 5 minus 2, and 7 to the 3 minus 4 is 7 to the third, 7 to the negative 1. Now do the add rule. 7 to the 3 plus negative 1 is just 7 squared. You also can make that 49 if you like it. Next one, let's do the negative 2 plus 5. Becomes 3 to the third over 3 to the 7th. Well, 3 to the third over 3 to the 7th is the subtract rule. And then the negative exponent rule becomes 1 over 3 to the 4th. You also could make that 1 over 81. So which of these rules do you need review on, or are all these super solid from middle school exponents? How are you feeling on it?